All right, so we're gonna wait maybe another minute or so to see if anyone else joins in here today. But um, just a quick mention about what I have shared right now. I posted a announcement in Canvas to let you know that you can download the example problems that we're going to be working on here. Let me check this real quick. Yeah, so you should be able um, to see the example problems that we're going to be working on. So make sure to download those, have those open, um, because you're going to have an opportunity to work on those throughout the class today, and then we will work on them together. So a couple things that I just want to go over here first. If I come in here, so touching on this first, if you took a look at your Chapter 2 homework, you would have seen some problems that you have to solve for where, um, where you have to figure out the classes for continuous data. And so we have talked about continuous data classes, and the way that we talked about it yesterday was something like going like this, right, where we have the decimals there. The wording is a little bit different in your homework platform. So in your homework platform, instead of going like 0 to 4.99, they would call that 0 to less than 5. And then you start your next class at 5, and that goes to less than 10. Um, and then that just encompasses as many decimal points as is needed. So when you see something like this as your classes set up in homework, know that these types of classes are only for continuous data. If we had discrete data, right, if we just had discrete data, our classes would be something like 0 to 4, 5 to 9, 10 to 14. Right? So that's our difference here between discrete and continuous data. So, are there any questions about that before we move along here? Okay. So, just wanted to touch on that before we got into anything too crazy here today. Now, make sure that you have that Chapter 2 example Excel file downloaded and opened. You can find it on Canvas. It's right underneath the Chapter 2 lecture slides. Have that open. We are going to be working on that here in a bit. I wanted to go through, though, and talk about an Excel function here that is going to be extremely helpful when figuring out frequencies, and especially helpful when our frequencies are doing a frequency distribution for categorical data, right? For data with words. So we have this function here that's called COUNTIF. And so what COUNTIF does is it tells Excel to look at your data and count how many times a certain thing is found in that data set. Right? So I'm going to recommend that you become comfortable with something like COUNTIF, because in your homework you're going to have examples of maybe like 50 or 60 data points. There's a chance on your exam that I give you 500 data points, that I give you 500 of each of these types of numbers over here in column A. And then when that happens, you don't have the time to go through and manually count it yourself, right? So that's where count if is going to be helpful for us. So if we come down here into our frequency distribution, and remember how every single time that we wanted to use an Excel function, we needed to make sure to start off with an equal sign. So we start off with our equals and we go count if. And we do an open parenthesis. That's going to ask for two different pieces from us. It's going to ask for our range and our criteria. Our range is telling it where to look. So this is telling Excel, okay, I want you to look in column A, right? All of our data is in A, so we can just select the entire column. Then we put a comma. And then that is now asking for the criteria. So it's now asking, what do you want me to actually count? And if we reference this cell here to tell it to look in all of our data over here in column A and count how many times 0 appears, close the parentheses, and hit enter, we can see that there are 14 times that 0 appears. Now, you could go through and do count if and do it over and over again. But like we talked about last week, we can drag down functions. So if we drag this function down, we can now see all of the different times that each of these individual numbers are being displayed in our data, right? Because when we drag this down, our criteria is changing each time as well. So are there any questions about using count if? So the C5 is the criteria for this. Right, right. Yeah, we're counting what's in this cell over here. Okay. Any other questions about this before we move on to those example problems? So you definitely could put that as your range. If I wanted to, I could come in here and just select all of my data and have it show up as A2 to A72. Now, if I do that, I'm going to want to freeze those cells. Because then when you drag down, it will only look at those cells as your range. So we put dollar signs in front of everything there. Right, right. If I just choose column A and click up here where we have the A and we get the little down arrow, then we don't have to put any kind of dollar signs. Yep. So any other questions? Okay, so we can get out of that and come back here. All right, so I did a little bit of research yesterday. These are the 5 most popular paint colors of 2022. So I want to be able to see now a frequency distribution from this categorical data. So we have to figure out the frequencies and the relative frequencies for each of these 5 different paint colors. Once we have that all figured out, then we can see that we need to create a pie chart showing the relative frequencies of the paint colors. So I'm going to give you a couple minutes here to work on this. When you are done, let me know over there in the chat, and then we will reconvene and talk about what to do here. All right, let's work together on this one here. So, what did you guys do to figure out the frequencies of each paint color? Okay, so this is why we went over count if, right? Because we can use count if here to find all of these frequencies. So if we go equals count if, it's going to ask for our range and our criteria again. Our range is where all of our data is. Our data is over here in column A again, so we can choose that. Our criteria is going to be the different types of paint colors. So for this first one, it's evergreen fog. We close our parentheses, and we can see that there's 62 times that evergreen fog shows up in all of this data here. All right, we have, what do we have? We have 350 data points. Yeah, we have 350 data points. So 62 times evergreen fog shows up. Now, if we wanted to, we could redo our count if formula here again, select column A, and now select October mist as our criteria. And that gives us a frequency of 74. We could also just drag down our formula to be given all of our different frequencies. So, are there any questions here about how we found the frequencies of our different paint colors? Okay, because I can promise you that you are going to have to do something like this in your homework, and then more importantly, you're going to have to do something like this on your exam, where you are given a long list of information, of data points, and you have to figure out the frequencies. Now, yes, yeah, 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 yep. So all Excel is doing here is let's make this bigger. All Excel is doing here in this function is saying, look in column A, that's our range, to see if anything matches the information in cell D2. So it doesn't really care if it's a number, if it's a word. It's just trying to match up and see if things are showing up over here in column A. Cool, cool. So any other questions here about frequency? Okay. How do we find relative frequency? Perfect. So what's an easy way here in Excel to add up all of our frequencies? Equals sum. Okay. So if we use equals sum, we get our 350. Now, how can we create a smart function here where we will be able to pull it down and it will auto-populate all of our relative frequencies? So, close. We don't need the sum part though. So all we need to do here is equals, and then we choose that cell there, right? Divided by this 350 that we found, this total frequency. So if I hit enter, will I be given our relative frequency here? Okay. All right, so we get 0.177. So I pull this down and I get a bunch of errors telling me that I cannot divide by 0. So what do I need to do to fix this function up here so I don't get those error messages? The dollar signs. Yep, yep, we need to freeze our denominator, right? So now when we pull this down, we get numbers. So what is happening here is we're taking E2 divided by E8, and then this next one, E3 divided by E8, E4 divided by E8, right? So the numerator is changing each time, but the denominator is remaining constant. Now, if on an exam, let's say you forget to put in these dollar signs and you pull this down and you get this divided by 0 stuff. If you then just go individually and figure them all out individually like that, this information is still correct, right? We still end up with all of the same relative frequencies here. What's different is that that takes more time, right? So the dollar sign thing is really just there to help us save time, so then that way we can pull down a function and it'll allow Excel to do the work for us. Let's put it that way. So, are there any questions here about relative frequency? So we choose which side we want to be on, right? We either E2 or the E8, and then we can hit F4. If we hit F4, it will cycle through what you want the dollar sign in front of. And so the dollar sign tells it to freeze the following piece. So when there's two dollar signs, that's freezing the cell entirely. $8 means freeze it in row 8. $E says just freeze the column, and then we're back to nothing again. So any other questions here about relative frequency? Okay. So we completed our frequency distribution table to the point that we needed to. How do we create a pie chart showing the relative frequencies of the paint colors? Okay. So if we go highlight that, insert a pie chart. Now, if we add in our data labels here, notice that we are showing frequency, right? And not relative frequency. So, how can we fix this to make sure that we're showing relative frequency rather than just frequency? Okay, so it's all about how you choose your cells. So we want to choose our paint colors. Then we hold down Control and we choose our relative frequencies. So that's telling Excel we want this information here with our different paint colors, and we want this information here with our different relative frequencies. Now when we come up and insert a pie chart and add in our data labels, notice that here we're showing relative frequencies rather than just frequency amounts. Yes. Like this one over here. Uh, let's see. Did that do it? That did it. Okay. So you can just kind of move it along here. Yeah, I had no idea that that would actually do anything. So yeah, you can you can go about it that way. Um, there's going to be stuff later on in the semester where we have to select cells that are not right next to each other. So it might be good to get in the habit of holding down Control and selecting things. But if you forget to do that, yeah, there's always that workaround right there. And then, I mean, you can go in here and really mess with each piece, change the color of it, right? If we were trying to, match up the color of the pie chart to the actual color of the paint color, we could do that kind of stuff within a pie chart. So, are there any questions here over this categorical data? Okay, let's talk about quantitative data. So quantitative data, we start to get numbers, right? And we have a lot more stuff that we have to put in here into our frequency table now. We have our classes, our frequency, relative frequency, cumulative, and cumulative relative. But unlike categorical, where we can just make all of our different groups into the paint color names, we have to figure out what our classes will actually be. So, you guys remember the rule? Let me see here if I can. Oh, it's not going to let me draw on here, it doesn't look like. So, you guys remember the rule for the minimum number of classes. What is our calculation for that? Okay, so this was our 2 to the k power has to be greater than or equal to n. So we need to first figure out what our n is. And what does n stand for? Sample size. K is your number of classes. So K is your minimum number of classes, and N is your sample size. How could we find our sample size here? So we don't even have to add them up. We just have to count how many different observations there are, right? So we could think of this as like on day 1, we sold 66 units. On day 2, we sold 57. So how many days do we have? So the easiest way to do this is to select all of our data here. So that shift control down arrow, and then we come down here to the bottom right of Excel, and it tells us our count. And our count is 60. So that's telling us that we have 60 different data points here. So that becomes our sample size. So we need to figure out a K that would make this equation true, right? 2 to what power is greater than or equal to 60? So we can just go through and just try out different numbers, right? 2 to the 3rd power, well, that's 8. So maybe 2 to the 5th power, that's 32. 2 to the 6th power, that's 64. Right? So 2 to the 6th power is finally greater than or equal to our sample size. So that means our K comes out as 6. Right? This step here is just trial and error. That is the only way to go about this. Once you do it enough, you'll start to, think, hey, maybe let's not start at 3, right? And then you might start at a number like 5, and you'll be able to get it done quicker, but there is no easy way necessarily to go about this. So we know that we need to have a minimum number of 6 classes. Can we have more than 6 classes? Yes. Yep. Right. So we can go up by 3 if we need to. So we can have anywhere from 6 to 9 classes. Um, and we have that leeway in there. So in that way, our classes are pretty numbers. Our classes are numbers that we can actually work with. So we have 6 as our minimum number of classes. How can we figure out our approximate class width? Divided by your K. Perfect. So our max minus our min divided by K. So Excel has max and min functions. So we can just go equals max and select all of our data. So our maximum value here is 78, and then equals min for minimum, and our smallest value is going to be 5. So we can use those. We can go 78 minus our 5, all divided by our K. Right, so our approximate class width is our max minus our min divided by the K that you found in your previous step. We get that number kicked back to us. Is 12.167 a pretty number? No, right? There's no way that you can count up by 12.167. So, what would be a pretty number in this realm, in this area? Well, so ideally, so our data here doesn't have any decimals, right? So ideally, we won't have any decimals in our classes. And 12 is even pushing it when thinking about a pretty number. I would go, I'm sorry, what was that? 10, right? You have some leeway here. So use it. Right? 12 is better than 12.167, but it's not the best option. So our best option here is probably going to be 10. But what we have to do now is we have to figure out our classes. And we need to make sure that we're within the range that we found earlier. So if our minimum value is 5, that means that our first class needs to hold that value in it. What should be our first class then? How about 0 to 9? Right? And then that way, when we keep going up by 10, we can see that our first value here of our class is divisible by our class width. Right? So if we keep going and go 30 to 39, 40 to 49, 50 to 59, 60 to 69, and 70 to 79. Doing that gives us 8 classes, which is still within the wiggle room that we have here from this 6 to 9 that we found with our K. So are there questions about how we came up with these classes here? Okay. What I will tell you is that in your homework, Pearson makes it where your classes are not always pretty numbers. Go along with what they are showing. So they're going to have stuff like where it's 10 to blank, and you have to fill in the blank based off of other information. Go with what they're talking about in the homework. On your exam, I want you to try and have pretty numbers if you are asked to create classes like this. So, frequency. Let's talk about the easiest way to find these frequencies here. We can turn our data here into a table. Right? So we selected our data, and then we went format as a table, and we have our data in a table form. Once it's in a table form, we can sort it. So if we sort from smallest to largest, now we can go through and we can say, okay, between 0 and 9, there's 3 of those. Between 10 and 19, there's 7 of those. Right? We highlight the number, and then we look down here to see our count. And so if we keep going through 30 to 39, we have another 7. 40 to 49, we have 9. In the 50s, we have 11. In our 60 range, we have another 11. And in our 70 range, we have 8. Now you can always double check to make sure that you made your frequencies correct by adding up these numbers. And this needs to equal your sample size that you have up above. So you can select all of your data, and then up here along the Home tab, you have Format as a Table. And so you can just pick one of these tables, and then you'll have the option to sort it up at like the header of your table. So any questions here about how we figured out our frequencies? Okay. Relative frequency, we already did this. This is the same kind of stuff that we just did with our categorical data. So we can just create that same function and, oops, and get our relative frequencies that way. Now, cumulative frequency. Do you guys remember what cumulative frequency shows? Okay. If you had a cumulative final exam, that means that it builds on top of everything, right? Everything is covered in the exam. If snow accumulates, that means that it's being built on top of old snow. So our frequencies are being built on top of each other. So our first one is always just that class's frequency. But then our second one is here is going to be asking for what is the frequency from this class and fewer. So we can go and we can choose that 3 that we have in our first row for our cumulative frequency and add in the 7 for this next class's frequency. And so we can see that here in the second group, we now have 10. Meaning from 0 to 19, that many units sold, that happened on 10 days. And then we can keep going. The next one is the 10 plus this class's frequency of 4. So now we're at 14. Right? And because we're making this function a smart function, we can just drag that number or that function down and it will shoot back all the numbers for us. Right? So our cumulative frequency is just our frequencies adding on top of each other. It was just 3 at first, and then it was 3 plus the 7, and then it was the 10 plus the 4, the 14 plus the 7, and just continuing down all the way until we get to our last class. Are there questions here about this cumulative frequency? Okay. How would we be able to figure out cumulative relative frequency? You guys still with me? Okay. So, cumulative relative frequency is the same kind of idea as what we did here in relative frequency, right? Where we took each of our frequency numbers and we divide it by the sample size, the 60 down here. Cumulative relative frequency is we take each of our cumulative frequencies and we divide it by our sample size. And so we can go each individual one divided by our sample size. And then if we freeze that denominator again, we can go through and just drag the number down. So again, this is something that could show up on your exam. And it is something that is showing up on your homework. So you'll need to know how to do these frequency tables. Are there any questions about this frequency distribution? Okay. So part 2 of this problem asked you to create a histogram showing the relative frequency and an ogive showing the cumulative frequency. Um, we're going to talk about the histogram, and then if we have time at the end, we'll come back and talk about this ogive. So for relative frequency for this histogram, we want to select our cells again, just like how we did with that pie chart back with our categorical data. Right? We select our classes, and we hold down Control, and we select our relative frequencies. We go into Insert. Here's what I would recommend whenever you have to create a chart. Click on Recommended Charts and see if anything pops up. So, a histogram is a column chart without any gaps. So when this first chart pops up here under recommended, we should be happy with this because we can click OK and we can turn this column chart into a histogram. So this is very important here. This that we have right now is not a histogram. A histogram does not have gaps in between each of the bars. So we need to turn this into a histogram. So we click on any of the bars, and then you'll notice little blue dots around all of the bars here. We'll right click and we hit Format Data Series. If you're working on a Mac, I think it might say something like Format Data Point. So we click on this Format option, and some pieces pop up here over here on the right side. What we're worried about is this gap width. Right now it's at 219% for me. I want this number to be all the way down at 0, because as we drag this down to 0, all of a sudden I don't have gaps in between all of my columns. And I just turned this this column chart into a histogram. So all you had to do there was just get rid of the gap width between each of your different columns. So are there questions here about a histogram? Okay. Could you guys at least put something in the chat to let me know that you guys are still awake? Yeah. So it's different than relative frequency because we're taking our cumulatives and dividing it by our sample size. And that's really it. Yep. Okay. So, are there questions here around this? Okay. These next two are just going to be some quick things that we're going to talk about. So, we need to create a scatter plot to show the relationship between study time and exam grade. So, we have a bunch of data here around the amount of time that someone spent to study and the exam grades that they got. To create a scatter plot, all we have to do is select our X variable, our independent variable first, which is our study time, and then have our Y variable in the column next to it, which is our exam grades, right? Because the amount of time that we study leads to an exam grade. So study time is independent, exam grade is dependent. So we have our data here set up correctly, and we select all of it. Right, we have, what is that, like 103 different data points here. A scatter plot is just a chart. So we go to Insert, and here in Charts, down along the bottom row of your charts, you see these little dots. These little dots here mean that we want to put in a scatter plot. So we have a bunch of different options. We can have this with lines between all of them. And you can see that none of these really help the story. But this one, if we just create a basic scatter plot, click on it, and then we can see the relationship as the relationship between our exam grades and our study time. So there's a bunch of different things that we would be able to eventually talk about here, like stuff that we'll talk about in future chapters, like this trend line that we can add in. We can try and predict what our exam grade would be based off of a certain amount of study time. Tons of different things that we can get into once we have this scatter plot. But the importance is that we have our independent variable listed first, our dependent variable listed second, and then we just go Insert Scatter Plot. So hopefully that was a little bit simpler than our quantitative data one. Are there questions here about scatter plots at all? Correct. Yep. Okay. So your homework. Your homework could ask, which of these scatter plots best matches your data, right? And I mean, if you just look at your data, you might be able to figure out what that answer could be. Um, but if you create the scatter plot, it'll be a lot simpler, right? And so that's why I just wanted to cover that real quick. Now, contingency tables. I want to say that the vast majority of you said yesterday that you've already used pivot tables previously in Excel, which is awesome because we are definitely going to need to use pivot tables a lot more starting next week. But these pivot tables could also be helpful when creating frequency distributions. So I just wanted to talk real quick here about how we can create a contingency table using a pivot table here in Excel. So if we went through and surveyed a bunch of students and figured out what kind of pet they have, and I want to say that we have the options here of cat, dog, no pet, and other. So we have all of this data here to show what kind of pet they have and what class they are, a freshman through a senior. And we have a bunch of different data points. We can't really tell anything just from this data. So we'd want to create a table that has, freshman, sophomore, junior, senior. And then cat, dog, no pet, and other. This is what a contingency table would show us. It would be able to tell us, okay, how many sophomores have dogs? Well, I would look here to see where those two intersect. So we can create a pivot table to give us that information. So pivot tables are found under Insert, and we go Insert Pivot Table. And it's going to ask for some information here. It's going to ask for your table or range. So this is your data. So we can just select all of our data here. Then down below, it's going to ask, where do you want your pivot table to show up? We can have it show up on a new worksheet, or we can have it show up in any cell that we want here on this current worksheet. So here with my cursor in the location, I'll just say that I want it here in D6 or D26. And then I hit OK. And it kicks back to me our pivot table field. So we have this information over here on the right side. We have class and we have pet. It does not matter which one goes where, but one needs to go into your column and one needs to go in your rows. Then we need to have numbers in here somewhere. All right, so we will choose either one of our variables and we bring this down into values. Now, it's important when you bring it down into values that it shows up as count of whatever variable you chose. Because we have other options here. If we click on the down arrow and hit value field settings, we have other options where we could go sum, average, max, min, product. We just want the count when we're doing a contingency table like this. And then there we go. That's all you have to do. In chapter, yeah? Your chart doesn't look like that. What's different? Yeah, yeah. So highlight all of your data, go into Insert and Pivot Table. Right? We don't want a pivot chart. We want a pivot table. And that's going to show where your data is. And then we can just choose a random cell for it to pop back into. And then this is what it shows up as initially. Okay. Now, you can also notice our classes aren't in order, right? We go freshman, then junior, senior, sophomore. That's not terrible, right? We can work around that. But if we just go above sophomore, the cell that has sophomore, and you start to see that 4-direction arrow that we have here, we can click and we can drag and move columns and rows into different spots. So now we can show it as freshman, sophomore, junior, senior. So at this point, this is all I expect you to be able to do here with contingency tables. Still not showing up? Okay. So are you here in the pivot table? And if you click and drag one of your variables into columns and click and drag the other variable into rows, okay, and then choose either one of your variables again and click and drag that into values. Okay, I will take a look at it after class. So next week, when we get into chapter 4 and we start talking about probabilities, we'll talk about how we can use this contingency table to figure out probability amounts, to see, what the probability is that a junior has a dog. So are there any questions here about contingency tables, about using pivot tables? Okay. So a quick piece here about ogives. For an ogive, what you would have to do is re-put out all of our frequency information. And instead of having class of 0 to 9, we just put the minimum values for all of our classes. And then we will highlight that info. Oops. I'm sorry, we want cumulative frequency. I was wondering why that wasn't going to look very nice. There we go. Oops. Okay, so we want our classes and our cumulative frequencies. Then we insert a scatter plot. And we can, insert the scatter plot that has a line with it. That's how we can create an ogive. That is not something that I'm going to make you do on an exam, but I just wanted to show you here in Excel that you can make it happen if you ever need to at some point in the future. Right, so we find our class and cumulative frequencies and we create a scatter plot that has the lines in between each point.